Hello, welcome to therfinsights. In this video I want to demonstrate the software tool that I have created for a simple point-to-point microwave link design or study simulation. So this tool basically user can input some parameters for two stations, station 1 and the station 2, and there are some common parameters that are defined, and the tool is able to give you some visualization and also calculate some link parameters and gives you an idea of the antenna heights at both sides, or how much is the link availability. So one of the characteristics of this tool is that it is able to get the digital elevation terrain data for the area, and as well as it can model the rain using the Crain rain model that you can input the parameters for. So here on the left side of the screen you can see station 1, so user can input the parameters for station 1: latitude, longitude, antenna height, antenna gain, antenna 3 dB beam width, and feeder loss. So at the moment this tool only simulates antennas with parabolic roll-off. So the only things we need in terms of the antenna are its gain and its beam width. Here on the right side of the screen we have the same parameters for station 2. In the middle we have some common parameters for the links that needs to be defined, namely the frequency, bandwidth of the signal, transmit power station 1, transmit power station 2, noise temperature at both stations, rain rate and rain height in the area. So these two are used by the Crain rain model to calculate the rain fade. Your objective carrier to noise ratio, polarization, earth curvature factor. Here we have 1.3 by default, but you can change it. Number of time steps that you need to simulate, and step size or duration. Also, if you want to use P530 multipath model or no, you can turn it off. So in order to do the demonstration I can do some adjustments. These values that you see already on the screen are the default values, so when you run the software out of the bat you will see these values on the screen, but you can adjust them, right? So I want to adjust this in order to make the link a little bigger. Antenna height is okay. Antenna gain, I give a little slightly higher gain for this, and also I want a pretty narrow beam width antenna. So on this side again I make it 50. I want both the stations to have the same antenna pretty much. I bring it a little higher, 30 meter above ground. This one is 20 meter. I make it like 40 meter. Then I load the terrain model. So because the area might be big, I normally go above and beyond the coordinates that we have here. For example, for 43 minus 79, I start from 4378 up to 4380. Okay, then I go 44 78, and I go up to 80. So now I have uploaded my digital elevation model here. There's an option if you want to clear it and adjust your selection, you can do that. Okay, so I don't want to change anything else. Probably I need number of time steps. I increase it to 1000 steps, so it gives a better availability estimate for the link. Now first I have to push this compute, so it computes some of the parameters and does some of the visualization here. So if I push this, you can see it gives you the link length, the link, the azimuth at station 1, azimuth station 2, elevation at both stations. What are the absolute height of the antennas at both stations? How many obstructions the Fresnel zone has? You can see here. And the losses that are calculated here. So the losses, we have free space loss, we have multipath, which uses P530, we have diffraction loss, so this is calculated based on the number of obstructions that we see in the path profile, and the Crain attenuation using Crain model. And you can see the carrier to noise ratio at one time step at both stations here, which is pretty high right now if you look at it. Okay, so here if you see, we can see the side profile view here. So this is basically the path profile from station 1 to station 2, and for example, if I bring this station down a little, it is right now it's like 30, I make it like 15. Let's see what happens. I'm expecting this to change. Yes. This one is 40 meter. I make this one 15 meter too. So let's see how the profile changes here. Number of obstructions gonna increase. So right now we have like 36 obstructions, and you can see that the diffraction loss increased to 15 dB. Frequency is set to 10 gigahertz, right? If I increase this area that you see, shaded area that you see here, is the first Fresnel zone. So if I increase the frequency, for example, to 60 gigahertz, you're going to see the Fresnel zone should shrink, right? We have a narrower Fresnel zone when we go higher in frequency, that you can see here, and the losses are much higher. Especially the Crain loss, you know, for high frequencies is way higher. Okay, let's set it back to 10, and now we have the C over N for both stations, but we want in order to get an idea about the availability of the links, we need to run this simulation for a number of time steps, right? So now if you, okay, before that I want to show you the top view of the area. So this is the top view of the area, and this red line that you see is the link, right? So the link is located pretty much in this area that you see. Now if I run the simulation for 1000 time steps, it's gonna take some time, but these results are gonna be updated after it's done. Okay, the software generates this C over N curve for us, and you can see it's always above the 12 dB margin that we have defined. Therefore the link availability is 100%, as you can see here on the screen, right? So what we can do is we can like decrease the height above ground to like 5 meters at both sides. Let's see what our losses are gonna increase a lot. Then we run the simulation again. Let's see if it changes anything in terms of the C over N or availability of the links during the 1000 time steps. Okay, so still the availability of the link is 100% of the time, which is great. So we don't need to change much for this link. But it's I feel like there's something wrong here, because the link is pretty obstructed, and we still have 100% availability for the link. This could be because of the antenna gains are pretty high, you know. Yeah, anyways, so this is the tool that I've created. I would really appreciate if anybody is interested to like test the link for me, and it has any like problems, you can highlight it to me. I can make some changes, or I can add other stuff to it, you know. Thank you so much for your attention. Please don't forget to like, subscribe, and leave a comment. Have a good time.